Hello, welcome students, 10th class science students. Here I am going to solve the sample question paper class 10th science 086 for term 2, 2021-22 released by the CBSE. In the previous video, I have solved chemistry part of the sample question paper, and today I will be solving the physics part of the sample question paper officially released by the CBSE. As you already know, the general instructions have been explained by me in the previous video. Maximum marks 40, time 2 hours, all questions are compulsory. And section A has 7 questions, 2 marks each, section B 6 questions, 3 marks each, and section C 2 case-based questions, 4 marks each. Internal choices have been provided. A student has to attempt only one of the alternate questions. Okay, so let us begin the physics section. Question number 6 is from the physics. It is on the screen, student. Here he is talking of a simple motor, student. First thing, as I say, read the question very carefully and form a map of the question in your mind. What you have read in the NCERT, which chapter is this, student? You have already studied the magnetic effects of electric current. It is coming from that chapter. And you know what we are talking here, what he has given. It is a simple motor. It is a electric motor, student. You can see the diagram, electric motor. It is given in your NCERT book. Electric motor diagram is given in the NCERT book. In a school laboratory, a coil of wire is mounted on an axle. You know, there is a coil of wire mounted on an axle between the poles of a horseshoe magnet. See the poles of a magnet? North pole and south pole, north pole and south pole. So this is a magnet, and here you can see a coil. What is that? In the example above, coil A, B, C, D, A, B, C, D. This is a coil, student. A, B, C, D is a coil, student. And what is happening here is a battery. This is, you can see plus and minus. So the direction of the current is also known to you. You know the current flows from positive towards the negative side. This is the direction of the current, student. So fourth thing, we know there is a magnetic field, student, which is the direction of the magnetic field. You can see this is going from north to south. This is the direction of the magnetic field direction. You are going from north to south. And the current direction, this is the current direction. I is the current which is flowing, student, current direction. This current is flowing like this, and you have a coil A, B, C, D. A, the current is going from AB and going back from the CD. This is the battery, student. In the above, coil ABCD is horizontal and battery is connected as shown. All right, understood the question, seen the diagram. Now you already know that what we are talking about here. When a current is flowing into the coil, student, magnetic field is applied. What happens? There will be a force on a current carrying conductor. You have studied, student, you have studied. What you have studied? Force. Okay? Force on a current carrying conductor, on a current carrying conductor, okay, placed in a magnetic field, when it is placed in a conductor in a magnetic field, student. You know what happens if a current is flowing across a coil or a conductor. Magnetic field is applied, a force will be experienced. There will be a force, student, on this. It will experience a force. This will experience a force, and that is the principle of an electric motor. You know, electric fans, refrigerators, washing machine, computer, they all have got electric motors present in them. So basically, student, what has happened? A force will be generated on this coil. The question says, for this position, state the direction of the force on arm AB, student. First question, A. Direction of force Direction of force is given by which rule, student? You have studied Fleming's left hand rule, student. You can check the NCERT book at page 231 of NCERT. They have given you Fleming's left hand rule, student. Fleming's left hand rule. What is that left hand rule, student? What is the Fleming's left hand rule? How do you apply Fleming's left hand rule? We already know, student, that if I consider this is my left hand, this is my left hand. If this is the direction of the magnetic field, and this finger is the direction of the current, then my thumb is giving me the direction of the force, student. You have any doubts, you can check the NCERT book, student. Fleming's left hand rule. In this case, student, you can see the direction of the magnetic force is this. This is the direction of the magnetic field. The direction of the magnetic field is going like this, students. Current is in this direction, current is in that direction. Then what will happen? The force will be experienced downward. As what will happen? This AB will experience a downward force, student. For this, state the direction of the force on arm AB. The force on arm A will be, student, downward. So it will be downward. You can apply the Fleming's left hand rule if you have any doubt, student. First question is answered. That is based on the direction which we are saying is given by the force pushes it downward, and this will cause a anti-clockwise rotation. Another interesting question, number B, says, why does the current in arm BC not contribute to the turning force on the coil? Here you have a conductor carrying current and a magnetic field. What happens? We have found the direction of the force which will be experienced by the coil AB part. It is experienced downward. It will undergo anti-clockwise rotation as per the motor which is given to you. Then the question is, why does the current in arm BC? If I see the arm BC, student, this arm BC is parallel to the field which is applied. It is parallel to the field applied, and you know the force is 0 or minimum. When what happens? Force acting on a current carrying is minimum 0 when it is parallel to the magnetic field. This is parallel to the magnetic field. So what we know, student, BC, the BC arm is parallel, student, parallel to the magnetic field, to the direction of the magnetic field. So the result of this will be, student, the force will be force acting on this will be, force is 0 or what we say minimum. The force is maximum when the field and the direction of the current are perpendicular. This is perpendicular to this, so force is maximum here, and force here will be 0 or minimum. Once the force is 0, what will happen? It will not contribute to the turning force on the coil. This is the answer. Let us see the MS master scheme given by the CBSE. CBSE has given the following answer to us. First answer to be written in the exam is downwards, so you are getting 1 mark for that, student. Question was carrying 2 marks, and B part is because BC is in the same direction as the field line. So force is minimum, or it will be 0 when it is parallel, when the direction of current is same as the magnetic field. So BC will not contribute to the force on the part of the coil, will be cancelled by force and dA. So you get 1 mark for this. Total 1 mark plus 1 mark, student, you are getting. These are descriptive papers you have to write, and when I say write correct, student, and write the correct information, specific and minimum. Don't write too much, that's not required. 1 word 1 line answers are there, that is enough, not more than that, student. And this is the marking scheme which is released by the CBSE. So try to understand the questions before you answer the question, student. The choice is given here. The choice is given. A circuit contains a battery, student. Where is this? Is a battery. Okay? This you can see. This is our battery, student. This is my plus. This is my minus. This is a battery. A variable resistance. This is a variable resistant, as you can say, and a solenoid, student. First of all, check the NCERT book. What is a solenoid, student? Solenoid is a coil of many circular turns. It is a coil of many circular turns. You know about it. Coil of many circular turns here, student. In insulated copper wires. Insulated copper wire. These are insulated copper wire. Okay, which is wrapped in the shape of cylinder. Wrapped in the shape of cylinder. Students, try to understand everything. Question answer will be very small. I'm just trying to explain in detail. So this becomes a solenoid, student. So what happens, student, in a solenoid? Magnetic field will be produced, and the solenoid, you know, the solenoid, see the diagram in the book also, it behaves like a bar magnet. A solenoid behaves like a bar magnet, student, and one of the end of the solenoid is north, behaves like a north, other behaves like a south, student. So it behaves like a bar magnet, north and south. And what happens, students? Then you see the field lines are generated from north to south, student, in a solenoid. One end behaves like a south, other behaves like a north in a solenoid. Now the question is, as you see, the field lines are produced. A circuit contains a battery, variable, solenoid. The figure shows the magnetic field pattern. The magnetic field is, there is a magnetic field produced by the current in the solenoid. First question states how the magnetic field indicates regions where magnetic field is stronger, student. The magnetic field will be strongest where, student? So where there will be more crowding of the, where there is a more crowding of, there is a more crowding of field lines. The magnetic field lines where there is more crowding, you know, there the strength is more. And you will see that the crowding, as you can see inside the, here there is a lot of these lines are coming farther away from each other, but as they come closer, student, what is happening here? The field lines are coming closer to each other. There is a more crowding, and therefore the field lines are more crowded. There will be stronger magnetic field. Stronger magnetic field will be observed. This is important. And magnetic field you will find inside the solenoid. Inside the solenoid, you see the magnetic field lines become parallel. And inside the solenoid, the magnetic field lines are parallel, and therefore magnetic field is uniform inside the solenoid. And you know what is the solenoids are used to prepare electromagnets by using soft iron. You already know that. So first question is already there, where there is more crowding of field lines. Therefore, at that point, student, you will have a greater magnetic field. Question number B is saying, what happens to magnetic field when the current in the circuit is reversed, student? The direction of the current will decide which is the south and north pole. If I will do the reverse the current, what will happen? Then the direction of the magnetic field will also get reversed. So the direction of the field, the direction of magnetic field will be reversed. Student, if the direction of current is reversed. If direction of current is reversed. So let us see the marking scheme answer given by the CBSE. CBSE is saying the answer is given. Relative closeness of field lines indicates the strength of the magnetic field. As we said, the more crowding of the field lines takes place, more closer they are, then greater is the strength of the magnetic field. Since field lines are grounded around the ends of the solenoid, hence these are regions of strongest magnetism. Strongest magnetism is towards the ends of the solenoid. because at the ends of the solenoid, the magnetic field lines you can see are highly crowded. So it is maximum here. So this gives you 1 mark, student. The direction of the field will be reversed when the direction of current is there. So total you are getting 1 + 1. This is a marking scheme. Total 2 marks. Question 2 marks, student. All right. Another question is coming, student. It says it would cost a man 3.50 to buy. When we were talking about, student, the chapter of electricity, in that chapter you have seen we have tried to calculate the cost of the bills, electric bills which are coming at your homes. And you know the commercial unit of electricity, because he is talking of kilowatt hour. Student, kilowatt hour is the commercial unit of electricity. Commercial, some information is already with us. I am trying to explain unit of electricity. Commercial unit of electricity is kilowatt hour. The measurements of your electrical bills is done by this. 1 unit is 1 kilowatt hour, and he has given the cost of 1 kilowatt hour. How much is the cost? Rupees 3.50. So it would cost a man 3.2 to buy 1 kilowatt hour of electrical energy from the main electricity board. At your home, you have main electricity board, student. Meter reading is taken. You can take the meter reading. You can also take the meter reading, student. Okay? You can take the meter reading from your home. Main electricity. Okay? So meter reading you are take from that main electricity board is there. He has a maximum power of 2 kilowatt hour. The maximum power, which is the power which he has, is, student, 2 kilowatt hour. And you know what is power? Power is energy by time, student. Power is energy by time, or energy is power into time. Power into time. So power is 2 kilowatt. The generator produces energy at maximum power for 3 hours. What is the time here, student? 3 hours. Calculate how much it would cost to buy the same amount of energy from the main electric board. So what is the electrical energy, student? Here P into T. How much? 2 kilowatt and 3 hours, student. So how much it becomes? 6 kilowatt hours. So the total energy is 6 kilowatt hour, which is the commercial unit of electricity. The cost of 1 kilowatt hour is how much? 1 kilowatt hour cost, student, 3.50 rupees. Then what will be the cost of 6 kilowatt hour, students? 6 into 3.50, which is coming to 21 rupees. So this is the answer, student, in this question. Question number A is answered, student. Question B, let us see what is he talking about. Question B, student. In question B, he says a student boils water in electric kettle, student. You are aware of electric kettle you are using at home. Electric kettle you are using at home, student. What do you do? Electric kettle में पानी उबालते हैं for 20 minutes. For 20 minutes, student. Using the same means, he wants to reduce the boiling time for water. He wants to reduce boiling time, student. How will you do? You have the same electric kettle, lekin you to do so, he should increase or decrease the length of a heating element. You know there is a heating element. Heating element, you have studied the heating effect of current, student. Heating element is there. And heating element has got a coil, which has a length, student, L. Because there is a resistance, electrical energy is converted into heat energy, student. Now, how will he reduce the boiling time? If he increases the power of the kettle, increases the power, student, P of the kettle. The power depends on what, student? The power means what? What is the formula of the power, student? You studied. Power is equal to V into I, and V is equal to I into R is Ohm's law. So what you are getting? P is equal to, since V is the same, student, so what you are getting? If I put I is equal to V by R, so you get V square by R formula, student. So power is V square by R. That means to increase the power, power is inversely proportional to resistance. So if I reduce the resistance, power will increase. If I reduce the resistance, reduce R, and R depends on student directly proportional to length of the heating element which you are using. So if you reduce the length, the resistance will become less. Resistance will become less, power will become more. So what we have to say, student, then reduce the R means decrease the length of the heating element. Answer is decrease the length of heating element. We have to decrease the length of the heating element, student. That will be the answer of the. So decrease the length. Okay? Decrease the length, student, of the heating element. Let us see the answer given by the marking scheme given by the CBSE. E is equal to P into T, 6 kilowatt hour, which is equal to 21 rupees. So here you are given 1 mark, student. And reduce the boiling time. You know, we have already shown you this formula. Reduce the R. That means you decrease the length of heating element. Heating element, student. These are descriptive questions. This is the marking scheme given by the CBSE. No problem in solving this question, student. Another interesting question is based on the resistors. You know, this is important. A question will be there in the paper on resistor. Resistors can be connected in series or in parallel, student. Let me see here what I'm trying to say. Here, student, let us see the circuit first. Let me see the circuit, student, carefully. You have, this is the ammeter, current is given in the circuit, 2 ampere. Potential difference, that's a battery, how much? Voltage is there, 30 volts, student. And Ohm's law says V is equal to I into R. This is a circuit. If I consider effective resistance, what is the effective resistance of the total circuit? I can calculate by this method, student. So 30 volt is equal to 2 ampere into R effective. R effective, which is coming to be 30 by 2, 15 ohm is the total or effective resistance. The effective resistance in the entire circuit is how much? 15 ohms. That we have calculated. First thing. Here the question says find the value of R1. Where is R1, student? Let us see the type of circuit. R1, if I put this R2, if I put R3, student. R1, I don't know. R1, I don't know. R1, I have to find out. R2 is how much here? 10 ohm. R3 is how much, student? 5 ohm. They are in parallel. Okay? Please check it out. And you know what is the formula for the parallel? First, let us find the value of the RP, student. What is the resistance of these three? Start from the back side, student. Resistance of these three, RP. Formula is 1 by RP in parallel. 1 by R1 plus 1 by 10 plus 1 by 5. What will be the LCM of this, student? This will be 10R. If I take that 10R1 LCM, what I am getting? R1 10. What will be this? R1 5 to the 2R1. What is that? 10 plus 3R1 divided by 10. So what will be the value of RP then? Then RP will be 10 by 10 R1, student, divided by 10 plus 3R. Is it clear? This is equation number 1. So this whole circuit RP is equal to this much. Now this RP and 6 ohm are in series, students. See the circuit. This RP and these are in series. In series 6. So what is the formula in series, student? Let me apply the formula in series. Be with me, student. Be with me. In series, which are in series, student. If I take 6 ohm, 6 ohm and RP, these three are in series, means what? What will be the effective resistance then? Effective resistance will be 6 plus 6 plus RP, student. This is 12 plus what is RP, student? 10 R1 divided by 10 plus 3 R1. This is our effective resistance. Now effective resistance we have calculated to be 15 ohms. This is equal to 15, student. Then what do you get? Solve this. We have to solve this equation, student. So this is coming 12 plus 10 R1, 10 plus 3 R1 is equal to 15. Take this on the other side, student. 10 R1 divided by 10 plus 3 R1 is equal to 3. 15 minus 12, 3. ठीक है? 15 minus 12 will be 3. Cross multiply. What do you get? 10 R1 is equal to 30. 10 R1 is equal to 30 plus 9 R1. Take 9 R1 on this side. Then 10 R1 minus 9 R1 is equal to 30. So R1 is equal to how much then? Student, R1 is equal to 30 ohms. Okay, is it clear? So if the current reading is 2 ampere, what would be the value of R1? See the how I have calculated. Everything is clear. Let us see the answer given by the CBSE. Again, you see all these calculations have been done. What I have done in a very simple way. The answer is 30 ohm, student, and this is how the marking scheme. 1 mark, 1 mark, 1 mark. The steps, you have to do all the steps, student. Marks are given for the steps. Marks are given for steps. So you have to write all the steps, students. Then you will get full mark. Full mark. Okay. Let us see another question. Choice has been given. Student, choice has been given. He says calculate the, it is a circuit. Again, see the circuit, student. Circuit has been given. What is this? Battery, 24 volt. 24 volt battery. You have, student, this total circuit, in the total circuit 24 volt, student. Find the total current. Total current you have to find out in the circuit. Before that, formula is, you know, V is equal to I into R, Ohm's law. And how will you calculate I if you know V by R? So first you have to find R. Here I am saying effective. What is the resistance of this circuit? You have to find out R effective, R effective. So we have to find, student, R effective. That is the total resistance of this circuit. Let me start from this side. These two R3 and R4, student. R3 and R4 are in series. Then what will be the resistance in series? RS is sum of the two. 6 plus 4, it becomes 10 ohms. Series formula. Now R2 and RS. This is now my RS, student. R2 and RS, student. R2 and this R2 and RS. What is happening to them? They are in parallel, student. See the result of this? This whole circuit, I can replace it like this, student. This is how much coming? This is 10. This is also coming 10. This is my RS, student. Now in parallel means what will be the effective resistance? I use 1 by RP. 1 by 10 plus 1 by 10. How much is that? 2 by 10. 1 by 5. Then RP is equal to, student, how much it is coming? 5 ohms. So up to now, this plus this becomes 5 ohms. Okay? I have now this circuit. student, this and this whole becomes how much? This becomes a student, another circuit here 5 ohms. Okay, R, this is series, R series 5 ohms. Now these two RS and R1, they are in series. They are in series, students. So what is the value of this? Then what will be the effective resistance for the complete circuit? 7 ohms plus 5 ohms, 12 ohms. Is it clear? I am starting from the back side, taking the circuits, parallel, series, and then again series. Now finally, R effective is 12 ohms. Total resistance is 12 ohms. This is my total resistance, student, 12 ohms. Total resistance is coming to be 12 ohms. Then what is the total current? Total current in this is V by R, R effective. This is saying effective resistance. V is 24 and by 12, which will come to be 2 amperes. 2 amperes. And therefore the answer for this, you already got it. The total resistance is coming to be 12 ohms and total current in the circuit is coming to be 2 amperes. This is how you have to write the answer. Let us see the marking scheme given by the CBSE. It may be confusing, but see, the marks have been allotted. Marking scheme is like this. How the marks are given, student? Half, 1 and 1. So total, it becomes 3 marks, student. As I again and again repeatedly say, write all the steps, write all the steps. Each correct step gives you half mark. Each correct step gives you half. If steps are not written, you will not get full marks. Therefore, solve the question in a stepwise manner, sequence-wise, and you will be able to get full marks, students. Coming to the next question, student. Question number 15 is a physics question. This is a case study. Ansari sir, in an experiment in his class, Ansari sir is in a lab, student, physics lab. He is demonstrating an experiment. Now it is quite clear from the picture what is he trying to do. Spring. If the spring is a magnet, you know what the spring can do? The magnet can move, student, up and down. Magnet can move up and down. You know, when with a spring, what can happen? Moving magnet, as we said, magnet is moving. Moving magnet, student, and is a stationary coil. So here you have a moving magnet. Note down everything in your mind. You have a stationary coil. A stationary coil, student. This is a stationary coil. Then this is a north pole, this is a south pole. Galvanometer. What the galvanometer does, student? It is an instrument. What we use it for? Measurement of current. Is a device to measure current. It will measure the current. How it will measure the current? If a current will be produced, it will deflect. It will show deflection. This needle will get deflection, student, if a current will flow. A magnet is attached to spring. He says magnet can go in and out of the stationary coil. Based on understanding, if he lifted the magnet, released it to make it oscillate through the coil. The magnet is oscillating because there is a spring. It is moving up and down. What is the principle which Ansari is using to demonstrate, student? Answer A. What principle you have studied, student? Electromagnetic induction. Important, very important. And you know, Faraday did an experiment and discovered electromagnetic induction. So moving magnet can be used to produce electric current. What he did, what he knows, you already moving magnet can be used, student, can be used to produce electric current. Electric current is induced, student. And when magnet will move, what will happen? Their magnetic field lines will be changing. Magnetic field will change. There will be change in magnetic field, and this will induce a current. This will induce a current. That is the principle of electromagnetic induction, student. Most magnet is moving, coil is stationary, or magnet can be stationary, coil can be moving. All these are examples of electromagnetic induction. So what is happening when magnet will move and he will withdraw, student? What will be the result of that? The principle is electromagnetic induction. Already know about it. The discovery was done by Faraday. What will be observed when the magnet start oscillating through the coil? Explain the reason behind this. So when magnet will be observed, student, when you will move the magnet, what will happen? There will be an induced potential difference which generates an induced current. Induced current will be produced. And what will happen if an induced current will be produced? The galvanometer needle will undergo deflection. It will show a deflection. If it is going in on the right side, and if the magnet is stopped, if the motion of the magnet is stopped, what will happen? Then the magnetic fields will also not be changing, will not be varying. The current will become zero, and I will draw it again. The deflection will take place to the other side. So there can be deflection right, no deflection, and deflection to the left, depending on the motion of the magnet. Okay? So the induced potential difference is produced, which generates an induced current, in this. This is example of electromagnetic induction. See, consider the situation where the magnet goes in and out of the state. Two changes which could be made to increase the deflection in the galvanometer. How to increase the current, student? How to increase the current? The induced current depends on what factor, student? Induced current depends on what factors, student? One thing is that I can increase the stronger magnet. I can use a stronger magnet. Increase the strength of the magnetic field. Strength is more, then there will be more induced current. Or the another could be increase the number of turns in the coil. Increase the number of turns in the coil. The more the number of turns in the coil, student, what will happen? Then this will increase the induced current. The factors which we studied in your book, there is strength of the field, number of coils, and the type of material which we use. Soft irons are usually used because they will have greater. So then here there is the only two things we are talking about: stronger magnetic field and number of turns in the coil. So you can increase any of these, then it will produce more current. Now let us see what answer has been given. Marking scheme given by the CBSE. Sari is trying to demonstrate principle of electromagnetic induction. You are getting 1 mark. There will be an induced current in the coil due to relative motion of magnet and coil. Changing magnetic field induces around the coil generates induced current. What we talked of induced current, student? Using strong magnet, using a coil of more turns, you will get, what will you get, student? Total marks is 4. So 1 plus half plus half plus 2, you are getting 4 marks. Marking scheme is given to you, so very easy, you can easily answer. Next question is coming, student. Is there any difference in the observation in the galvanometer when the magnet swings in and out of the stationary coil? What will happen? We already told you, when the magnetic goes inside, the needle will get deflected in one direction. And when there is the motion of the magnet is not there, then 0. And when I will remove the magnet or change, what will happen? The direction of the current will be reversed. So this is going to happen in this case. Let us see the marking scheme which is given. When the magnet moves into the coil, the emitter shows a momentary deflection from, say, left side. Supposing it shows the left side. When the magnet moves out of the emitter, shows a momentary deflection now towards the right. This is due to changing magnetic field or flux associated with the coil. As when the magnet is moving, what is happening? The magnetic field or flux is changing, and the direction of the current is to the right or to the left. It is deflecting, and alternately flux increases when a magnet goes in and decreases when the magnet goes. And when magnet, if it becomes stationary, what will happen? There will be no change in magnetic flux, and it can show 0 reading also. All right, student, this is all about the physics paper, and the only instructions are read the questions very carefully and read the NCERT book thoroughly, and try to understand each and every word, each and every line. The principles and their applications are very important in electricity and in the magnetic effects of electric current, and certain rules which have been given to find the directions, like the Fleming's left-hand rule will be used. You should also be familiar with them. Okay, then I will see you in my next video, in which I will be solving the bio section of the 10th CBSE. Bye bye. My best wishes to all of you. Keep on sharing. This video is very important. This is uploaded in the YouTube. You can share it with your friends. Subscribe the channel, as we are solving more and more questions which are likely to be there in the coming exam. Important questions will be solved, and I have already uploaded all the chapters of 10th class step wise, content wise, and you can watch those videos and they will help you. And my best wish is that you score 100 out of 100. Bye bye.